All right, so I'm going to skip on down to 11, where we get into some of this inverse. So reference angle there, hypotenuse, adjacent, opposite. We have cosine again. So the cosine of x degrees equals adjacent 14 over hypotenuse 22. So here x is in the middle, and you notice that there's nothing you can do. If you multiply by 14 or multiply by 22, there's nothing that will help us get to x. So you have to do this inverse, where we switch the sides and our angle. So that angle will be 50.5 degrees. And our instructions did say to round everything to the nearest tenth. All right, for number 12, there's our reference angle. So hypotenuse, adjacent, and opposite. In this case, we have opposite and adjacent, so that will be tangent. Tangent of x degrees equals 25 over 78. So we'll do inverse tangent. The inverse tangent of 25 over 78 will give us our angle, which will be 17.8 degrees. All right, for number 14, we have our reference angle there. Hypotenuse and adjacent are the two that it touches. Opposite is the one that it does not touch. So we now have, the sine, which will be opposite over hypotenuse. That is the so. So if sine of x degrees equals 10 over 19. We'll do inverse sine, 10 over 19. And that will give us 31.8 degrees. Again, all of those angles have to be between 0 and 90. For number 15, it says to find DE. So this is what we are looking for, DE. Now, there's multiple different ways that we can do this, but pretty much what happens is we need to have this side to be able to use the other triangle, right? So we don't have a side in any of these except for CF right there. So we have to find DF, which both triangles share. So pretty much anytime you're using a trig ratio, all you need is an angle and a side, and you can find any of the others. So if we're looking for this one, I'm going to call this Y. If we're looking for DF, C is my reference angle, and in this case, my hypotenuse is here, this is adjacent, this is opposite. Okay, so we have opposite and adjacent, and that will be tangent. So the tangent of theta equals opposite over adjacent. So the tangent of 61 degrees will equal opposite, which is y, divided by 24. So how do we solve for this? We just multiply by 24 to both sides. And y will be 43.3. All right, so now I'm going to erase what I have here. And I'm just going to say that this is 43.3. So now you see it's pretty easy to find this last one. We'll do our reference angle here. This is hypotenuse. This is adjacent now. And this x is opposite. So if we have opposite and adjacent, we're going to use tangent again. Opposite over adjacent. So the tangent of 19 degrees will equal opposite x over adjacent 43.3. And then you will multiply both sides by 43.3. And x will equal 14.9. So that's our final answer. Instead of calling it x, we can call it what it is, DE equals 14.9. And that is our final answer. So you can see that all you need is an angle and a side to be able to do any of these trig ratios. But understand that it does have to be a right angle. These trigonometric ratios only work for right angles. Right triangles, yeah. So for 16, we'll do the same thing. We need to find this one in the middle right here. So they give us 25 and 15 over there on the right triangle, XYZ. So we're going to use that first. And I'm going to call this y again. Right, so here's our arc. Y is our hypotenuse. This is adjacent, and that 15 is opposite. So that we have sine, because it's opposite over hypotenuse. And the sine of 25 degrees equals 15 over y. Y is what we're trying to solve for. So we have this rule where we can switch these, and that'll be y equals 15 over the sine of 25, and that should give us 35.5. So that is our length of this side right here, 35.5. All right, so from there you can forget about the other triangle. Now we're focusing on this one, and it's asking us to find the measure of angle W. So angle W right there is this angle. We don't know that one. That's what we're trying to find. So I'll put my arc around it, and that always touches hypotenuse and adjacent. And 35.5 is going to be my opposite. So the two things that they gave us were opposite and adjacent. So that means we are using tangent. So the tangent of x degrees, because we don't know that, that's the measure of angle W, will be opposite 35.5 over adjacent, which is 22. So we do the inverse tangent, and we're switching the places of the angle and the sides. And that will equal x, which will equal 58.2 degrees, which is well within our domain of what the angles could be, of 0 to 90. And the measure of angle W is 58.2 degrees. There is our final answer. All right, two more. If a ladder is leaning against a wall, it makes an angle of 75 degrees with the ground. So in other words, if here's your wall and there's your ladder, and obviously the other side is the ground, and that's 75 degrees, we know it's a right angle. It says the foot of the ladder is 6 feet from the base of the wall. So here's the base of the wall. They're saying that it's 6 feet right here, this distance. So if this is 6, what is the length of the ladder? They're asking the length of the ladder. Sometimes they could ask, hey, how high up the wall is the ladder? But they're asking the length of the ladder. So I'm going to erase my L and W here, and I'm going to make this X. So all they're doing is asking you to create the triangle. After this, it's pretty simple. We have our reference angle, hypotenuse, adjacent, opposite. Adjacent and hypotenuse is what we're going to use, so that's cosine. So the cosine of 75 degrees will equal adjacent 6 over hypotenuse x. That's what we're trying to figure out. That is the trick where we switch them. And that should give you 23.2 feet. And make sure you do use feet because it said 6 feet from the base of the wall. That's the unit that we're using. All right, last one. Jaden is flying a kite and lets off 275 feet of string. If the kite is 150 feet above the ground, and assuming the string is straight, what angle does the string make with the ground? Okay, so here's Jaden. And then he's got his kite. And then that kite is a certain distance above the air. And here is the other line with the ground. So he lets off 275 feet of string, and that kite is 150 feet above ground. Okay, so all we're asking, we're not trying to find that third side. If we were, we'd use Pythagorean theorem. All we're asking is what kind of angle does this string make with the ground? So there is our reference angle. 275 is hypotenuse. The ground is adjacent. 150 is opposite. So if we have opposite and hypotenuse, we're going to use sine. All right, so sine of theta equals 150 over 275. And then we're going to use inverse sine. And that'll be 150 over 275. And that will give us our angle. And that angle will be 33.5 0.1 degrees. There's your final answer there. All right, so if you guys got any questions, feel free to let me know. Shoot me an